The live stream is live, so we are going to go. So welcome, everybody. Welcome to Circuit Launch, the future of AI in hardware and robotics. Here in Oakland, California, my name is Jeff Frick, and I'll be hosting this panel tonight, and we're excited to have everybody here, both locally, an amazing turnout here in Oakland, as well as online. Good morning, good evening, and good afternoon, wherever you are. So first I want to introduce our panelists. First we have Catherine "Cat" Scott. You all know her. I think she talked to half the people in the room when she came in. She is the ROS developer advocate for Intrinsic, an Alphabet company. She's also on the board of the Open Source Hardware Association, and she's been playing in the robotics space for a little while. Cat, great to see you. On Cat's right is Dominic Lee. He is the roboticist in residence here at Circuit Launch. He's probably helped a lot of you guys with your projects. He's also the founder and CEO of Gyro Palm. So anything you want to control with your palm, you can do it. And in fact, it's now a leading edge device that's going to take a whole different direction beyond just your wrist. So Dominic, Kat, great to see you.
Thanks.
So let's jump in. And getting ready for this, I tuned into an interview with the founder of OpenAI, and he was talking about the future. And I thought, what do you guys think about this? And one of the things he talked about that was critical is that this is really a power curve function. This is really an enabler to help people do more with what they have. And it's a step function, potentially easy to see from kind of the chat, a little harder to see maybe from robotics and hardware. So I just want to get kind of your reaction to what's going on in the marketplace since ChatGPT hit the news and suddenly everybody has an interest in applied AI and generative AI specifically. So why don't we start with you, Dominic? You've got the mic.
Yes, thank you. So I think that OpenAI is on a very good new trail. Being that they've existed for quite a while now, they've used to open with GPT-3, and now with the advancement of ChatGPT and GPT-4, I think it's very momentous of an event here. We're living in great times because AI not only now can generate content that exceeds expectations of predicting the next words, but also it would be able to effectively communicate concepts, dynamically draw up interfaces, and just make a very positive impact towards industry. Like we feel, at least my team and I, we feel that it could be very momentous for roboticists and engineers and scientists as well in all of these aspects.
Kat?
I'm a little bit more reserved. ChatGPT and robotics, there's applications, right, with like HCI, like human-robot interaction. But like the more interesting things are like NERF right now, like solving problems slightly better than we solved them before, I think is going to be the more interesting part. I'm a little bit more reserved, though. I think these things take a lot longer to actually happen than we give them credit for.
Yeah. Well, like you said, he talked about it as a productivity accelerator. It's all about, and then you talked about some of the challenges. But in the productivity accelerator, it's even like when they had the original OpenAI and they asked the guy, how are you going to make money? And he said, well, hopefully the OpenAI will get smart enough we can ask them how we're going to make money. So kind of this whole self-improvement and learning is pretty interesting. And some of the really simple concepts that we're seeing is using something like the chat to write code and to pull things that are maybe available but not so easy to find for the regular person. What do you think?
I think the interesting one would be, the most interesting ones I've seen have not the ones that you put in something short and something long comes out for code. So you have a big short message, you're like, I'm going to store, and it turns into like a huge paragraph. The interesting ones are really where I have a long paragraph. Most people have trouble making things short and concise and clear. So I'm more interested in taking a big bad pile of code and getting rid of a lot of it. So I think we got a little ways to go.
Yeah. Dominic?
I mean, I'm a cross-platform developer, so I'm giving my very holistic feedback. Is Kat is right to a good extent that although OpenAI might have a ways to go in terms of growth, however, it is very much doing very well as it is right now. For example, a lot of use cases, there's billions of dollars of use cases in the industry where users are programming robotics manually. But let's say you have a script that does this one particular use case very well. You have another script that does another use case very well. Well, ChatGPT or GPT-4, so to speak, can combine both of these scripts together as long as they're the same language or even a different language. And that might be able to create very meaningful use cases that we haven't seen before. Or if we have, it would take users a very arduous time to achieve.
Yeah, well, and Sam had said that that was part of the, part of the objective. But I'm curious in some of the essential elements that are happening in robotics and how that then plays, not specifically for ChatGPT or even OpenAI specifically, but just kind of this next wave of these large language models, which have been around, but the compute and the horsepower and the networks and the clouds now enable it in a way that it just couldn't do it before. And guess what? Tomorrow there's going to be a lot more horsepower available than there has been before. It's interesting, Kat, watching some of your interviews, getting ready for this really small atom almost level assembly that people can do with all the components between running the actual robot, but then actually starting to put together the behaviors and stitching it all together. It seems like there's a real rich opportunity to change that process and make it a little simpler under the guise of democratization, which is a huge thing we see in all technology, letting it be available to someone who maybe doesn't have that lower level of programming skills or knowledge, but maybe abstracts it up a level to make it more accessible to more people?
Well, I think the democratization is going to come when, the models are there. Those are cool. Those are useful. The democratization comes when, if you've sat around and had to go build something on AWS and it's taken you 3 weeks and you have to figure out what part, configure it, it's that kind of stuff, those hard, just really boring problems of putting everything together that once you sort of automate them, that's what democratizes things. You condense something big into something simple, and a lot of times that simplification is people doing work. I think a lot of the AI tools are going to come in on some of the harder problems, the computer vision problems, some of the language learning models. But I don't necessarily see it writing that much code in the future. Hope, if it could write my tests for me, I would be really, really happy, because the tests are the thing that's always missing and the things that are really, really useful.
Yeah, I'd like to add a note to that as well. With a lot of this democratization, this is not to discount the advancement of what NVIDIA has done as well in the field of AI. They have released this amazing CUDA engine where, with the power of PyTorch, there's a lot of things that you can achieve, like backwards propagation and other AI computer vision tasks. So aside from OpenAI, I'd like, developers, perhaps some developers might know more in these areas too. With computer vision, you're certainly not limited to what OpenAI has to offer, but actually there's quite some open source libraries, like for example, PyTorch, Scikit, and so much more.
Right. And I think the democratization too comes from the save as. I just, everything I listened to getting ready for this, the whole concept of save as, which is a layman's term, but starting with models, starting with so much of it that's already assembled, and for people that are specializing in a particular area, and then going in and starting from that and not starting from zero, and then starting to make the little tweaks and applications. It was another interesting thing Sam Altman said is, he sees the future. So where's the future for people? Right, when more and more of the stuff is automated, and his point was it's that nuance on that special application where you take the 90% that's already done in the basic model, and then you use your specialty knowledge and expertise to drive down on that smaller set of data to unlock that value. Are you seeing that?
Like I've done medical imaging work in the past, and I don't think we're going to get rid of the doctors. I think you're just going to make the doctors more effective. It's not. I don't think everything's going to be blown out of the water completely, and none of us are going to be working tomorrow. That would be kind of a problem in certain respects. I think there's advancement, and there's also hype cycle, and we kind of got it. We're probably up here, and we're going to come back down here, and then we're going to come back out the other side, and things are going to be much more interesting.
Right. Yeah, there's certainly waves, and it's not perfect. So I definitely agree with that. We still have a ways to go, but it's an exciting one though, because it's now become an engineer's friend. Engineers' tools or doctors' friends to frequently, reference the AI as a means of knowledge, as a means of ways to do research. So it definitely opens up new doors here.
Yeah, everyone remember Amara's law, right? Don't just know the hype cycle. No, Roy Amara We tend to overestimate impact of technology in the short term and underestimate the technology impact in the long term. I saw some study from Pew. They asked people how much AI is in their lives today. Most of them missed. They missed spam filters. They missed the directions to get to the meeting that they were at to take the survey. I mean, they missed so many things. This stuff is so pervasive in our lives. It just takes a little while to seep in all the different places. One of the things I think that's interesting to get your take, you guys train robots, is kind of general purpose versus specific purpose, and that kind of opens up a different way potentially to train the models using these large languages. How do you think about that opportunity? Where do you see as kind of not necessarily the challenges technically, those will be overcome, but kind of opening up this capability to somebody that maybe doesn't have the right context to make the right decisions?
Well, general purpose versus like specific purpose. I'm still not sure we're going to see any like general purpose robot doing anything and everything. I think we're still very much in the domain of you have a robot, it does these sets of things well, because that if you have one robot that apparently does everything, it generally does nothing and no one's going to buy it. So if you have a robot that does one thing well, like clean your floor, I'll buy that robot for $100. And I would encourage people to look at specific hard things specific hard problems that are being solved. The most interesting one, like I came across a robotics company this week that is just doing rebar, that can do like house level. It's like a giant 3D printer essentially that you put over a house, and it can lay down all the rebar. Now that's something that's amazing and useful, and people will pay to have rebar set. And those are the kinds of things, those very specific things that we can finally do now, are the things I think people are going to pay for in the future.
Yeah, I think that is very coherent with what I'm about to say as well, which is it is very important to find a good use case. When you have AI that's driving a robot, or whether you're trying to integrate something and make a robot versatile, to have a very pinpoint use case for what you intend to do with it. But of course, with the advancement of AI, though, it allows robots to be more adaptable. And that means, unlike before where you program one action to one use case, now you can easily change it up. So for me, I have a vision of having something like a performance measurement inventory model, where I believe that almost all industrial companies have. You'd either use your robot to perform a task, or you'd use your robot and attach sensors to do thermal imaging, let's say, or certain scans, or in biotech, you would use that to do spectrophotogrammetry. And then the other one is inventory, which is, for example, what Amazon is doing with robots. So these, as long as your use case revolves around something meaningful, I think it could be very promising and gives very good outcome.
Yeah, the piece that is kind of again independence, but it's still operating within a box, is say like a Skydio drone. Which I don't know if everybody knows Skydio drone, but their basic design principle from day one is it should not crash. And that's how they built it, and they don't crash. Right. And what's interesting is because you don't actually fly the drone, right? You program a mission, you tell the drone what you want it to do, but you don't actually, get into the level of the flight. And to me, that was just striking to see that. And then again, that is now something that's available to a lot of people, and kind of opening up more independence, I guess, or I don't know what's the right descriptive term, the bounds in which the robots can operate efficiently, or the kind of outer limits of what you define. Is that really changing significantly now as these things get so much more compute and horsepower?
Well, I think what they've done is they've solved one thing. All of software engineering ends up being like accretive, right? So you solved one thing really, really well, and everyone can use it. They solve that, and then you can go and add the next thing onto it, the next thing onto it, the next thing onto it, and that's where you talk about democratizing. It's taking those parts that are solved really, really well that somebody else solved, and being able to smush them together with something else and build the next thing on top of that. The problem with that approach is that each time you aggregate something, you're going to need to go through and sort of redo the verification, validation, that the thing isn't going to screw up. And and that's kind of where we still don't have a ton of data on these models of like being really, really good. Do you want one of these models doing surgery on you yet? No, we're not quite there. And it takes a long, it's like autonomous vehicles, right? It takes a long time to verify and validate. We have millions and millions of miles, and we're still not ready to say they're really ready. It takes a long time to do V&V.
Exactly. And just to add to that, and I very much agree. So just to add to that, for example, autonomous cars, like when we drive, for example, right, we look at the other driver's eyes. You know, for example, if we have an autonomous car, there's no driver, you can't see the other driver's eyes, or these subtle cues that we as humans, we do. So I think there's one certain thing that if AI needs to advance to the level that we can accept it on daily life, every single release of these models can't have an accidental regression where it goes backwards, back to square one, because as we know, AI is volatile like that, right? And as long as we have this volatility, it becomes a little difficult to scale up. But I think it could be solved to a decent extent, and I'm looking forward to what companies are doing to address those areas.
Right. I want to shift gears a little bit and talk about anthropomorphism. Did I say it right? I didn't say it right. Making robots look like people and putting people attributes and dog attributes on these machines compared to like a Roomba, right? And it's this really interesting, it seems like there's a kind of battle for the PR between things that are simulate people versus efficient machines at cleaning the floor, doing whatever they're supposed to be. On the other hand, there is a PR game here. There's always a PR game in terms of the acceptance of the machines, people's comfort with the machines, people getting scared of watching too many movies. So as you think about kind of people's desire to want to make these things human, is that a necessary evil? Why is it so predominant? Why are all the machines we see in the news ones that look like people? And even the invitation for tonight, right? It was a couple of rock and roll robots that look like. Where does that come from? Is it a problem? Is it an opportunity? What do you think?
So there's been interesting efforts, right? So like when DARPA did this, right, the argument is we have a huge capital investment in things that fit humans and work for humans, and it'd be really cool if we could slap this thing in there and it would drive for us, it would operate the machine for us, which is a strong argument. I got my start working on cockroaches, like robots and actual cockroaches. I tend to take the opposite approach. It's that, like, if we learn anything through evolution, you had single-celled organisms, you had multi-celled organisms, you had stuff slowly creep on the ground, and that I think we're probably going to see more of a slow evolution. It doesn't mean don't do like a humanoid robot. I just think to get to that point, you'll probably want to see a lot of the steps in between before you see something that's really anywhere close to people. And it's going to be really creepy for a long time in between.
I'm going to approach this in, my engineer's perspective, right? So as an inventor and engineer, I have to say one thing is when you're building a humanoid robot, anything that you build, first of all, we're humans, right? So we intuitively want human-centered design, human-friendly design. In fact, that's very much aligned with, as you guys know, Apple, the designer of Apple products, IDEO, they focus on human-centered design. So I believe that human-centered design is also very important. But then there's also one very big challenge that poses a big challenge to engineers who do these robots is if you're going to have a humanoid robot do a fine motor skill. For example, I can move this cup 1 millimeter to the right? But if you want to do something that fine with a humanoid robot, the precision kind of goes down when you're trying to do all these things along with the aesthetics. So that's always been a challenge, and I think that it might continue to be a challenge that people might have to overcome.
Yeah. It's interesting. People fall in love with these things, right? They can't help it. So shifting gears a little bit about digital twins and simulations and really using robots to do things that either we don't want to use people for, or we have to run a lot of cycles, or it's dangerous. It seems like a lot of simulation opportunities are huge for robots, and this is a big piece, kind of an extension of digital twins with a little bit of a physical twin as well. When you look at that opportunity, what gets you excited, Kat?
Well, I mean, that's a huge one, right? Because a simulation is effectively the imagination for a robot, right? You got to be able to try something, you got to think through it before you actually do it. The difficulty is actually building the stupid thing, right? Like we don't understand a lot of physics really well. Like, I think a lot of what OpenRobotics did is we have this weird physics that we gotta put into this thing. How do we get that physics in there? And the whole modeling of complex physical phenomena that we may or may not understand, that is also semi-chaotic, is a problem. But I think we're getting to a point where we've got the first order stuff. We're kind of getting some of the second order physics effects. It'll still be a while before we get the third, but you don't necessarily need it all the time. There's a good enough point too where it's probably fine.
Yeah, like with what Kat said is one thing about that I definitely appreciate with ROS, because as a longtime ROS developer, there's a lot of great things that ROS offers, like the robotics operating system. For example, they've mastered the art of transform frames. They've mastered the art of inverse kinematics. So anyone, even if you're not good at math, right, you could ask potentially ChatGPT, hey, write a package for me that simulates a robot in Gazebo or simulates a certain type of robot that's two-legged and things like that. And with enough experimentation, you could do that even if you're not necessarily a roboticist. So ROS actually contains a lot of great packages that could really push users forward, even if they're not particularly experienced in this domain.
That's great. So one of the things that comes up often, again, researching for this, is the multidisciplinary approach that people come into robotics from. And it's really interesting. I think I saw you're doing one podcast, it was like an engineering podcast. You're doing, all these different multidisciplines. There's computer science and hardware and software and physics and all kinds of things. We're in a period of reskilling. The great resignation has turned into the great layoff, which is now, I think, the great reshuffle. People who want to get into this space, who aren't into this space, I would imagine there's a lot of potential opportunities and probably a lot of open recs for people that need help. How, for people that are outside of this world, how should they think about entering if they see an opportunity and they want to get involved? What are some of the ways that people can get involved in robotics in 2023? I'll start with you, Dominic.
Sure. So I believe that there's a lot of great things that could be done for anyone, beginners, intermediate, or experts to actually get introduced in robotics. The first things first is there is a wonderful location, a website called the Construct Sim. That's where you can actually get some free courses and free open classes every week to learn how to use ROS and ROS 2. There's another one that is about ROS 2 on Udemy, and actually there's quite a few of them about AI and other aspects. But for anyone who's interested in particular with ROS and ROS 2, there's a lot of courses like that. And in addition, I would have to definitely give credit to the wonderful folks here at Circuit Launch. Just being as part of this community, you get to learn a lot. A lot of things happen, especially things that happen in the community here at Build Night, etc. So just by being at one of these events, you're pretty much guaranteed that you at least have a great start to building meaningful connections and actually coming forward. And then finally, we have Gyro Palm has its own community of developers as well, and you're more than welcome to join us. So we actually develop robots and wearables as well.
Said my answer for me. So part of it, ROS certainly helps. I think the other thing that's good for robotics education in general is just going back to simulation. Robots are generally really, really expensive, and simulation is just a computer that you probably already have. So that's the first thing that's really important. I deal with a lot of, I administer a lot of the websites. I see all the students coming in and stuff. And I think the biggest problem I see is people biting off more than they can chew in general. Like, you have to start small. Like, you don't necessarily have to learn it all at once. Like, learn a little bit of software, learn a little bit of ROS, learn a little bit of electrical engineering, and then kind of go that way. Because what I see is, you have somebody who's just getting started, and they're like, I'm going to go build my own car, something very ambitious, let's say, and it's like then it's hard to start. So keep it really small. We offer normally I have slides. There's like a ton of websites I can offer you that are all free. Like ROS.org will point you to most of them, but there's lots of different ways to start, but start small.
Start small, always good. Get the early win. So shifting gears a little bit about security. Security is a problem. The increasing attack surface from IoT means that basically everything can be weaponized. My favorite story once was going through a thermometer, an automatic thermometer at a fish tank in Vegas to get into the systems at the casino. So you guys are putting these things everywhere. It's all Raspberry Pi. Everything's connected. When you start to think about security, and I want to layer on that too, we had a couple of people, I think from Verizon, talking about 5G and what the opportunity now with 5G and potentially small private 5G networks opens up in terms of what you can do in the field of robotics.
Right. I believe security is very important. Just like you said, it's very important because every single day there's more cyber attacks than the other. There's millions of hackers, billions of hackers out there that can, infiltrate towards different routes of applications. And having worked with a few startups and helped them, there's a lot of development teams that think, hey, we're going to build this application. We're going to write this script for this robot. We're going to worry about security later. No, the answer is not worry about it later, because more often than not, some people think that security is just slapping SSL on a robot. That's very far from the case. The truth is, you have a lot of routes that you're going to expose in the application, especially if you're going to make it interoperable. You need to make sure that every single route is protected, encrypted end to end, and not only that, but your data back and forth, that you're only sending it to secure places. And in addition to that, if you're working with embedded, know that sensors play a big role too. Just like you said, Jeff, if somebody were to take an air canister, spray it under a motion sensor in a door that's motion activated, they can open it on the outside, right? So for example, if that sensor is highly dependent on, motion to be activated, and you have a slot to enter that door, it's going to open. That's the same that applies to robotics and everything else.
Security's, there's lots of different ways that you start looking at security, and like there's the software side, right, which is like generally software that gets used more and banged on more and people actually pick it apart and put it back together is more secure than software where it isn't. Those sorts of organizations have software by obscurity. At least with ROS, right, we try to at least keep things patched. I know everyone hates it when your phone or your laptop says please update me, but that's kind of important that you have to update things all the time. And then people generally are the biggest link in security systems, and then just getting people to lock their screens, use security tokens. So you probably should look at yourself too much before you look at just your robot too. That's a whole other side of it, is that the people are the security problem.
Yeah. That's very true. My friend Rachel Tobeck has a 100% success rate in social engineering securing, calling people and getting access to whatever she wants. Live on stage from Blackout all the time. We are going to take questions. If you submit them through the Slack, we've got a curator who's going to pump them up to me. So if any questions for the crowd, you go ahead and start throwing those in. I wanted to talk a little bit about the impact of mobile and these things. Specifically in the way that they've driven down the price of sensors and really kind of opened up, a huge step function of, I'm sure, what you were excited to get your hands on in terms of accelerometers and GPS and, all the things that are in here now that they make billions of them, that, cameras are cheap these days. How did that kind of change robotics when now the components involved in these types of things start to get a whole different level of scale, or have they?
There's the component. If you can get the components, right now, which you can't always get, the components have gone down in cost. The one-off manufacturing costs have really, it's still difficult to make 10 robots, right? You got to do the layout, you got to send it out, you got to get the parts. So the parts have definitely helped. The form factors have definitely helped. If you want to use one of these as the heart of a robot and plug stuff in, it's great for a prototype. It's not something you normally sell commercially at scale. So it's components. The cameras are getting better, but there's certain aspects of this, these cameras fix a lot of things in post-processing too, which is a problem. Usually when you do a robotics application, you want an actual lens, and you have exposure compensation and stuff like that you don't always see in the cell phone cameras. They're really kind of engineered for their specific application.
Right. I very much agree. It's if you want to do DIY robotics, or STEM education, for example, that might be a very opportune thing. I mentor a lot of students from Purdue University and some other schools as well. They actually work with robots, and having sensors be affordable is one of those key areas. But I wouldn't use something in production, perhaps, right? Just like Kat said, I wouldn't use something for production when it has to rely on a certain piece of hardware that could be very limited, although cheap. But then if you're wanting to go in production, it has to be done at scale. But yes, that's a very good point.
Yeah. Dominic, I want to double click on something you talked about a little bit earlier, and that's AR, but instead of artificial reality, I'm going to call it augmented reality, because I think that's really, and you mentioned it, where the real big opportunity is to, the classic industrial case where you can look at the machine and your goggles tell you all the specs behind what's going on in the machine, and then to actually be able to control the machine with your wrist, it's a whole different thing. So when you look forward and you kind of set a vision, potentially with your customers, or you're trying to map out, what do you see in the future? Not that far down the road, a couple years down the road, and how this is really going to play out.
Right. That's a great question. We actually are, my team and I, we're actually opening up a new framework called the VIMPACT project. And Gyro Palm VIMPACT is essentially something that stands for Virtual Interfaces for Multi-Protocol Augmented Reality Activation-Based Control Transfer. That might sound like a mouthful, but what it essentially does is, have you heard of the Palm E project by Google? So essentially it is the idea of using human spoken instructions to control robots. Now, it is only as effective as it is if you have a laptop in front of you. I'm sure many of you, when you control a robot, you see a lot of people holding a laptop in experimentation, or you see like a big, heavy teach pendant, right? Now, we're actually breaking those barriers. We're making it lightweight, with a pair of AR glasses, basically bringing those visualization tools that used to be heavy on a laptop or GPU-powered things. We're pairing it up with AR glasses so that the AR glasses can use context-based situational awareness. And in addition, with our Gyro Palm wearables, we're pairing it up and calling it Spectrum. We're making this an open platform for developers to develop with, and making it one of the first packages to release on ROS 2, so that developers can actually use this to, for example, for use cases in industrial automation or navigating a robot in hazardous places, right? You can't always bring a laptop with you. Now, I love the Panasonic Toughbook and things like that. Not endorsed by them, but there's very heavy-duty tablets. But the idea is, when you have your hands full as a worker, what would you say if you could double or even triple your productivity by doing things while you are monitoring a robot remotely? That's the whole point of Project VIMPACT, is we feel it could be very meaningful, and that's why we're partnering with Vuzix and other folks to make this possible, so that humans can remotely stream video on their Boston Dynamics robot dog, for example, or a remote camera like the Oak D Lite. With that and computer vision algorithms, that could mean a lot, for both the operators, executives, and other people.
Right. I'm going to shift gears a little bit to you, Kat, because you've been doing this for a while. What do you wish we were talking about instead of AI in robotics? What as a long time that, what do you wish was getting more attention in robotics that's not getting the attention that it needs, and potentially more investment that has a kind of a bigger opportunity, or at least a bigger short-term opportunity?
The planet's burning and people don't have houses. Let's build robots to fix that stuff. Like, straight up, there's way other harder problems that need to be solved and need to get funding for it.
Yeah.
And people don't have health care either. And nurses are burned out. The robots and nurses thing is kind of maybe helpful, I think. We'll see. There's some cool stuff going down in Texas right now, and also in Singapore. With just, nurses end up moving stuff around hospitals all the time, and they my aunt's a nurse. They all throw their backs out by the time they're 55. It's a stupid hard job. So some of that automation might help.
Yeah, it seems that it's more helpful for nurses than doctors itself, because you could get items from point A to point B.
Well, and it gives, and the more interesting thing, and I think we forget this, is people are like, let's automate away the nurses. It's like, no, take away the things that suck about nursing and allow the nurses to do more of the thing that they're actually good at as people, and that's the difficult part there.
It's a good point. And that's kind of why hands-free is very important as well.
I heard some crazy stat that nurses spend, I'll script the number, 50%, 25%, 30%, looking for equipment. Just trying to find the equipment that they need right now for whatever the particular procedure is. So, so many opportunities are around robotics specifically, but IoT probably even more general in terms of keeping track of this stuff, internal navigation, so many opportunities. But yeah, there's some big problems in the world right now. That is for sure.
Yeah, the coolest ones I see are just companies just doing painting, drywalling. There's people out here in Oakland pulling nails out of reused lumber, so we don't have to cut down more old growth lumber, the stuff that was 2,000 years old that they cut down when we all moved out here 150 years ago. They pull the nails out of it and they can resaw it and reuse it. That kind of stuff is the amazingly useful stuff that isn't, it's not hype. It's a real thing that somebody can use. It may not make $1 trillion, but it'll make money. It's a useful thing.
It's like the autonomous vehicles that you don't see in agriculture, right? You don't see in mining, and you don't see in a lot of places that are working in geofenced areas that are, it's a controlled environment, but most people don't see it. They don't see what's going on. But I want to shift gears a little bit, Kat, because you are an expert in computer vision, not more than computer vision, but computer vision. I saw this great Autonomy Day, Tesla 2019, Andrej Karpathy talking about their decision not to use LiDAR to go with just vision, because I think, as Elon Musk said, lions don't have LiDAR. But then I was watching one of your videos. The LiDAR explosion is amazing. Now there's LiDAR on a chip. I wonder if you could just share, kind of what's happening in the advances in computer vision that's now enabled because of the horsepower and because of some of the things that we have going on that we didn't have before that get you excited, because you've been in this space for a little while.
Well, I mean, there's excited. I mean, I think we're kind of at this point where you saw where things were headed. I think computer vision's going the same direction. Like, we get better models, faster models. You combine 3 models, and they now I can segment and annotate and do something. The driving thing, I think you're going to have 15 different sensors in a lot of applications. Radar actually works just as well, and LiDAR works in some domains, but all of a sudden you get fog and LiDAR doesn't work. So, I think it's always going to be multimodal, and I'd be a little, building an autonomous car is like building a plane, and if it's not triply redundant, maybe it's a problem. The computer vision stuff I get interested in is that all the cameras are based on all the cameras we've ever used is RGB, and all of a sudden we get FLIR cameras, and people are like, oh my God, you can do that? You can see temperature with a bolimeter? But the reality is that every other creature on the planet that sees in different parts of the spectrum for different application spaces, and we completely forget that. So I think slowly you're seeing these, 15 channel, 50 channel hyperspectral cameras that would do things like recycling sorting, right? Almost all plastics look the same, but if you use a hyperspectral sensor, you can actually tell the constituent chemical composition of each of those different plastics and sort them. So those are the things I'm more interested in right now.
Yeah, a little wider spectrum cameras, if you will. Right.
Spectral imaging.
Right. Dominic, I want to shift gears to you a little bit and talk about kind of the human-robot interface. Your product specifically is about gesturing and human gestures,
right,
and using those as control. When you get into the nuance of human gesture, I suppose it's got to get pretty tricky, and there's got to be a lot of little subtlety. How do you, kind of break that down to do this transfer between a really subtle human gesture and very specific instructions for the machine?
Right. That's a great question. So I think that human-computer interaction is very important, because just like back in the day, gestures are used more frequently than speaking or that form of articulation. But gestures, the reliability of using gestures is even more important than the gestures themselves, because machines have to first know what your intention is. So human intent is what we focus on, and what technologies are supposed to do is not only when you do a gesture, it's supposed to recognize what gesture was performed, but where you did it and what exactly you want that to imply. So, gesture implications is one thing that our patented technology, Gyro Palm, is based off of. And also the second thing is having users be able to remember what those gestures are is very important. And that's why we have, we emphasize the one-shot gesture learning. So for example, if I wanted this to turn on the lights, I should not be told, hey, as a user, you got to do this to turn on the lights. I could technically do this to turn on the lights if that's what I'm accustomed to. For example, we have customizable gesture learning algorithms, and that is a form of its AI itself. It's edge-based AI that we run on our wearables, but you could actually change the gestures. We actually offer many opportunities for users to figure out how that works for them, and by understanding not only what gesture I perform, but what location I'm in. For example, I'm in the kitchen, I want to turn on the stove, right? The wearable would know exactly where it is, and that means a whole difference, because I could double dip or triple dip the existing gestures.
Thank you for that. A lot of nuance there. I've got a question here for the crowd. I'm going to give this one to you, Kat. AI and robot ethics, what are your biggest concerns? How are you working ethics into this thing? Because data and data privacy and security is there, but then ethics is this whole different layer.
You got 2 hours? No, I mean, there's all no. These people, you can smell the barbecue. People are hungry. I don't want to stand in front of them. You know, there's a lot of ethics involved with the AI issues right now, and you know, where is the data coming from? Who picks what's in the data set? Who annotates the data set? You know, what does it actually work? There's got to be, you know, I think the real question is, when are we going to get, you know, when are people going to start saying, we need like independent third-party validation of the performance of these models before they go out and do something that may impact different people differently. And that's my primary concern. Is like I said, the problem is always verification and validation. Who's doing the verification and validation, and what have they found, and can we all see it before something goes out there in the real world?
Yeah. But the other problem that comes up a lot in software is where, you know, you collected the data for a particular project for a particular use, and you were approved and that was an ethical use, but then suddenly it gets used for something else down the road, either the data itself or the report for a different thing. And that's where, you know, it can get really tricky on the ethics thing. I think we had another question coming in here for you. We're going to go with Dominic. What are the most skills in demand for robotics companies right now?
I think the most, you know, prominent skills that are in demand would be engineering traits, engineers that could have the skill for computer vision. And not only that, but using computer vision to perform fine motor skills. That's just like how, you know, not necessarily performing a surgery, but doing fine motor skills like assemblies, doing fine motor skills without necessarily hand-holding or human instruction, or at least minimizing that. So those are going to be a very important roles that we see next, because robots are not always as smart as we think they are contextually. We have to hand-hold them all the way.
Yeah, it's interesting. I had a friend who had an AI company, and he was doing an application basically for people to schedule appointments with each other, kind of like Calendly. And the nuance and the way in which we describe getting together, super, super complicated. And I actually reached out to him. I'm like, how is this going to dovetail with this crazy amount of detail within a specific application space? And that's really what he said, that these general purpose AI models are just not going to be there. But when you get into the specific domain, you get into specific vocabulary, all the common terms, you know, you need to be much more dialed into a particular realm.
Calendars never work when you want them to. Like, they try to suggest, you said 7 p.m. Can I insert something at 7? You're like, no, not now. You should have read the email.
All right. Check in here for the next question. I want a big shout out to our sponsors. This is the first of, I believe, 12 events that are being put on by the Hardware Collective. We got all the companies up here, Studio 45, Circuit Launch, Silicon Valley in your pocket, Silicon Valley Robotics, and Port Labs, and you can see the next event happening at Studio 45 next month. So as we get here to the end, you kind of already answered this in terms of what are some of the new sensor capability and new things now that you can plug into this ecosystem that you're pretty excited about.
Recently, I mean, that we've seen depth cameras come down in price and proliferate, that have like onboard processing and like have industrial connections and not cost $5,000. Those are always good things. I don't know, what bit of hardware have I seen? You know, I haven't seen anything recently that's blowing my socks off, but you know, that's like the past month. I'm not building a robot right now. What do you?
Well, I mean, I actually encourage an open development. You know, we love the fact that developers want to develop something. I mean, who here has heard of hackathon before? You folks have heard of hackathons? Yeah? So we actually really encourage users to develop with ROS and also develop with our wearable technology. I mean, in fact, we're going to have a hackathon tomorrow at 6 p.m., the same place, Circuit Launch. So if you folks want to try some hardware, I mean, you're free to join. I mean, we'll have food just like we do tonight, but we're very happy to invite people along this community. You know, community is what we're all about.
That's great. And I did see that fingertip thing that you pointed out from the show. The guy was striping it, and the sensors very intense from the last show that you had the
Yes, it's Honda Research Japan.
Is that what it was?
Oh no, Shadowhand. UK.
pretty crazy. Pretty crazy. All right, well, we're getting here towards the end. Is the barbecue up? Any barbecue ciders back there? I think that's about it. I think we got most of the things. Oh, last thing, actually a big thing, open source. The impact of open source on this whole space is tremendous, and I don't think people put enough emphasis on how open source as an ethos, as well as a software development strategy, as well as even moving into agile and managing people and projects, has had. And again, going back to kind of this save as concept, where you can start with something that's already been done and build off that. Such a critical component, not only technically, but really for the community. Kat, again, you're the community developer person. You're in the community every day. You're going to all these shows. You're talking to these people, looking at cool things. How important is open source? Could this even happen without open source?
I mean, personally, I don't think so, because just these are things, right? If you look at the arc of some of these things, these are multi-decade long arc sort of development processes to actually get somewhere, and you make some progress, you stop, you make some progress. Open source is kind of the ability to say, well, I did my little bit, let's just put it out in the world, somebody else can pick it up. And, that's how ROS has been evolving for well over a decade now, and Gazebo and all the other libraries that we work on. I guess, can I plug stuff? Can I plug two things? If you're interested, all right, if you're interested, we're doing a ROS meetup down in Mountain View at the Intrinsic offices on next Thursday at 6 p.m. I will personally go buy 30 pizzas. You can come eat them and chat. I got some cool speakers. If you feel like flying to New York let's see, I think it's the 28th, April 28th, we're having Open Hardware Summit, first one in 3 years. If you do hardware stuff and open source hardware stuff, love to have you. All of the cool people on the East Coast that do open hardware will be there.
That's great. Yeah, I think open source is certainly a blessing. Like we wouldn't be where we are without open source, and I think a lot of you would agree with that. So that's why, for any open source developers out there, we highly encourage you continue keeping open source. I mean, we're the community, and Gyro Palm open source is almost all of its code, and we highly urge all the companies out there to provide open source as this means of advancing humanity, because only then we can understand what's going on and continue making a positive impact.
Well, we are super excited to have you both help us here with some insight. So let's have a big round of applause for Kat and Dominic. It's an exciting future. And I think with that, we're going to say goodbye to our live stream people and head to the barbecue in the back.